Let's talk about the paper BAO, making learned query optimization practical. First, let me introduce the paper summary. This paper will propose BAO, which was a system that uses reinforcement learning to make the query optimization more practical and efficient. We can see CI have a workflow in the bottom side, which was a traditional query optimizing thing. First, it will input the SQL language, which we taught it in the class. And after it, the SQL language will be put into a optimizer, which will simplify the query. And after that, it will be executed and get the final result. For this traditional query optimizer, there will have some problem, which like inefficiency. It will need a long time to train, and when the database change, it will have wait lot of time to adapt it, and also have the tail latency. Let's talk about the bulk. Bulk method, which was a new method, use the TCNN and the Thompson sampling to make the optimizer more efficiency. We can see the graph at the left side. The top one, which was the whole workflow of the bulk working, and below it was which was the workflow of a easy example. Let's talk about this one. First, we can see it will input a SQL language, which we will talk it in the class. And after that, it will give some hint for the SQL language, like it will give some hints if the SQL language say we need to use the join, and the hint will say we can change it into the loop join, hash join, and the merge join. And after that, we go to the predicted performance, which will give the real time that estimate to run the plan. And the reinforcement learning will choose the minimum time one, like the merge plan. It only needs to 18 seconds for it to estimate. This the workflow of the ball. After that was same as the traditional uh, query optimization. It will execution it, and after that we will get the result, which was the merge plan and the actual latency, which was 38 seconds. And the actual latency and the result will be put into the train model to train, and it will help it to improve the predicted performance more accuracy. For the contribution, the main contribution for the ball will improve the optimization efficiency, and it also will reduce the latency, and which will easier to extend to the commercialize. Let's talk about the related work. First is about the NEO. NEO is a previous work for the query optimizer. Uh, like NEO, which was a full AI model that directly generate and simplify the query plan, which we can see the difference between two graphs. NEO will replace the query optimizer to a whole AI suggestion machine that will give the fast way to solve the query optimization process. And we can see BAO will not replace the whole query optimizer, it will give some hint. For us, an example, the new just like a GPT will directly give the student the answer, but the BAO will more likely a teacher will give students some suggestion to solve the problems. This was the difference between these two. And the bulk suggestion was based on the cost modeling and the culinary estimation. Let's talk about the evaluation. Um, for the data, it will based on three data sets, which was the IMDb, stack, and the COP. There was basic information for these three data sets. Uh, for the first evaluation, we talk about the train time and the convergence. In the right side graph, we can see there have some compare between the ball and the PostgreSQL default query optimizer. Before the 2 hours, we can see bulk efficiency was much lower than PostgreSQL, but after 2 hours, we can see there have a obvious improvement for the number of query finished for the bulk method. So Segment bulk method was very easy being used in the commercial life optimizer and also will maintain the stable performance under the dynamic workload. The second evaluation is the tail latency analysis. For the data, we can get the result was 99, cutting the 99% of the latency from the 130 second to under 20 second, which means the 1% slowest query optimization process will being compressed from 130 seconds to the 20 seconds. And the most of its performance gain come from the improvements in the slow tail queries. And the third one is comparison with the previous optimizer. We can see the graph over here. We compare the ball neo, sorry, DQ and the booked grade default optimizer. Between these four optimizer, we can see the ball have the best performance in for during four other optimizers, and also it also work well in the stable query and the dynamic query, which means we can easily to insert and like delete and do some change for our database. It's very important for the commercial life and use in the real world. Let's go to the work critical part. First, let's talk about the well-developed aspects. Ball works easily with existing query optimizer and quickly improve their performance. Just same as we talked it before, Ball will just give some suggestion for the optimizer and use the reinforcement learning to get the best choice of the suggestion. And compared to the training a full model, using Hink is a lightweight solution and making it practical and efficient. So it also means the bulk method is very easy to deploy in some commercial machine or commercial data sets, which will very useful in our real daily life. The other thing is about the self-improvement. We can see the ball will combining the TCNN and the Thompson sampling, which means ball can learn from the mistakes and adapt effectively to change, and it further improve its algorithm based on latency feedback, which we can see the ball will use the neural network um, to fix its mistake by the actual latency uh, in the loop over and over again. So it will also improve its own accuracy at that time. Supporting developer aspect is I have 2 points. First one is the limited option, and the second one is the weak early performance. For the limited options, Ball can only choose from a fixed set of hints, which limit its search space and may cause it to make better query plan, reduce its potential for higher performance. So this is something worse than the full AI model, because full AI model will make maybe to discover its own hints or own plans to solve the query problem. But the bulk method only can choose from some limited stack. The other thing is the weak in the early performance. Ball does not perform very well at the beginning and need time to get the experience and feedback before showing clear benefit. So it can may be limited in short term or fast changing scenarios. Uh, This aspect we will already see in the evaluation, the first part, training time and the convergence. It will show the bulk performance before the 2 hours will not show not very good. The third one is about what could have been done differently. We think we can combine multiple learning methods, not only the reinforced learning. Because reinforced learning alone cannot fully use the global advantage of hints. We can combine it with something like the supervised learning or like machine learning. It can improve the training and the optimization. Because something like the supervised learning it will very excel to learn some global pattern for the data sets, and also it can find something new from the hint. And the reinforcement learning will focus on to find the best choice of the options. So combine these two method will maybe have some more efficiency way to solve this problem. The final one is about the need additional justification. The reinforcement learning is in dynamic scenario need to more to prove. In this paper, it only shows the ball can adapt to data and the workload change. But more tests are needed to see if it stays stable in more complex and fast change real situation. Finally, let's talk about the subject improvement. First thing is about the experiment. We can design a new experiment to test about more types of data sets and dynamic scenarios to verify its stability and generalization in different environments. Uh, which we can do some text in the real world scenario, like say I have lots of insert, delete, and create some tables and schemas, which will all will be happen in the real world data set. So we will text the ball into six situations and to text the performance for it. The second thing is add more hints. Add hints or SQL paradigm to give the system more choices during optimization, improving decision quality and help it find better query plans. Just like we talked it before, we want to combine the supervised learning and the reinforcement learning to improve the performance, which is these two learning methods can do their best in their aspect. Um, it also will give the hint for more choices, and the more important thing, it will have self-study and the ability to fix the mistakes during the process. The last one is applied to real-world system. Deploy ball in cloud database, large distributed system, and a more complex dataset based environment to evaluate its real-world impact and performance improvement. We will see in the real world nowadays in some cutting edge area, the database will not be deployed into one machine. It will based on the cloud system and anything like that. We want to take the result for ball to deploy in the machine. Okay. Here was the reference, and finally, thank you for your watching.